light passes through the medium part of its energy. The medium part of its energy is absorbed and part is scattered. Is absorbed and part is scattered. I ask again. When light passes through, the medium part of its energy is absorbed and part is scattered. Full stop. Part of the energy is absorbed. Part of the energy is absorbed by the atoms and molecules, of the environment, Part of the energy is absorbed by the atoms and molecules of the environment. Full stop. As a result, light intensity decreases. As a result, light intensity decreases. Full stop. By the use of colorimetry, we measure optical density of substance. Optical density is D. Please, can you see the blackboard?
Oh, yes.
Optical density is D. Optical density is D. Optical density varies for different substances. Optical density varies for different substances. Optical density varies for different substances. Full stop. Intensity of absorbed energy is proportional to the concentration of the substance. Full stop. This fact,
Teacher, repeat it, please. Is proportional?
Yeah, is proportional to the concentration of the substance. Full stop. This fact serves as a basis. For concentrative colorimetry. The photometric method for measuring of the concentration, of the substance in transparent medium. This method, full stop. This method allows the measurement of blood saturation degree with oxygen. Full stop. Our aim in this laboratory work, calculate unknown percent solution of kali potassium. Our aim in this laboratory work, calculate unknown percent solution of kali potassium. Now write in your copybook the reference table. Watch. This is our reference table. Can you see, please? Please, can you see the blackboard?
Yes.
1 minute.
Yes, we can see, doctor.
Okay, yeah. One minute. In our reference table, lambda is electromagnetic waves length. Lambda is electromagnetic waves length. We have different electromagnetic wavelength on our device, but we measure optical density when we have 490 nanometer. You understand?
Yes, teacher.
Yeah. Known concentration is C, and it is 2%, 4%, and 8%. 2%, 4%, and 8%. D is known concentrations optical density. D is known concentrations optical density. We measure in the first, second, and third experiment known percent solutions optical density. Dx is unknown percent solutions optical density. Dx is unknown percent solutions optical density. At last experiment, I measure unknown percent solutions optical density. Cx is unknown percent solution of kali potassium. My aim, calculate its values. But I have concentrated, I have photocalorimetry, and with this device, I can measure only optical density. Now write, what is optical density? The optical density of a material relates, the optical density of a material relates to the tendency, the optical density of a material relates to the tendency of the atoms of this material, of the atoms of this material to maintain, of this material to maintain the absorbed energy of an electromagnetic waves. I repeat once more. The optical density of a material relates to the tendency of the atoms of this material to maintain the absorbed energy of an electromagnetic waves. This method we used in medicine when we want to measure optical density or unknown percent solution. Now I start my experiment. We know we have 3 known and 1 unknown percent solution of kali potassium, and in first, second, and third experiment, I measure known concentrations optical density. I ask again. 1 minute. Can you see the device?
Yes, teacher.
This is a device of concentrative colorimetry. A device consists, this is display, what display? With the display, I can measure optical density. This is door. Under the door, we have table, what? We have table. On the table, we have 2 cuvette, first cuvette and second cuvette. In the first cuvette, always we have water, and when I start my experiment, I measure water's optical density, and we know it is 0, but when I start my experiment, I measure it again. In the second cuvette, I put known and unknown percent solution of kali potassium. In our experiment, we have kali potassium. In the other experiment, I can take other solution. The table is moving. What? The table is moving. What is this? This is an electromagnetic waves length. We have different electromagnetic waves, but we measure when we have 490 nanometer. I ask again, we have 3 known and 1 unknown percent solution of kali potassium. 2%, 4%, and 8%. When I start my experiment, I take 2% solutions and I measure its concentration. I put it in my cuvette and I measure its optical density. Now I close the door. When I start my experiment, I measure water's optical density. It is 0. What? It is 0. Now I moving the table. And when I'm moving the table, 1 minute. When I'm moving the table, I measure 2% solutions optical density. It is 0.25. I write the values in my reference table. Now I change my solution, and in the second experiment, I measure optical density when I have 4%. This is the water. With the water, I wash my cuvette, and now I measure 4% solutions optical density. What? This is 4%. Again, when I start my experiment, I measure water's optical density, it is 0. Now I am moving the table and I measure optical density when I have 4%. It is 0.54. 0.54. Again, now I wash my cuvette with the water. And now I measure optical density when I have 8% solutions. When I start my third experiment, again, I measure water's optical density. It is 0. Now I am moving the table and I measure optical density when I have 8%. It is 1.5. Again, I wash my cuvette, and at last experiment, I measure unknown percent solutions optical density. I write the values in my reference table. When I have 8%, optical density is 1.5. At last experiment, I take unknown percent solutions optical. I take unknown percent solutions and I measure its optical density. Again, I measure water's optical density, it is 0, and unknown percent solutions optical density is 0.4. Can you see, please? 0.4. Tx is 0.4. My aim, calculate unknown percent solution of kali potassium, but I ask again, we measure the device by which we measure only optical density. Now I take the coordinate system. This is D. This is D. This is C. C is concentration. This is optical density. Now I take the coordinate. When I have, this is 0, 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, 1 point, 1.1, 1.2, 1.3, 1.4, 1.5. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I take the coordinate with my known concentration and known concentrations optical density. When I have 2%, optical density is 0.25. Now I take my first coordinate. This is 2%. This is 0.1, 0.2. What? 0.25. I take my first coordinate. What? This is my first coordinate. When I have 4%, it is 0.54. Can you see, please?
Yes, teacher. Yes.
0.1, 0.2, 3, 4, 5, 54. I take my second coordinate. This is my second coordinate. And my last coordinate is 1.5. When I have 8%, optical density is 1.5. I take my last coordinate. What? I have 3 coordinates. Now I build up the graph. This is my graph. My aim, calculate unknown percent solution of kali potassium. I know unknown percent solution optical density is 0.4. Now I take my last coordinate with my graph. 0.4. What? This is 0.4. I drew the perpendicular on my graph, and other perpendicular are my unknown percent solution of kali potassium. It is 3%. Do you understand or not?
Yes, teacher.
With my graph, I can measure unknown percent solution of kali potassium. Now I ask again our laboratory work, and then you can answer the question first laboratory works. Our aim in this laboratory work calculate unknown percent solution of kali potassium. We have 3 known and 1 unknown percent solution of kali potassium. In the first, second, and third experiment, we measure known percent solutions optical density. When I measure known percent solutions optical density, I take the coordinate system, I take the coordinate, and then I build up the graph. At last experiment, I measure unknown percent solutions optical density, and I take my last coordinate with my graph. My last coordinate values is unknown percent solution of kali potassium. Do you understand or not? What is
Yes.
optical density? The optical density of a material relates to the tendency of the atoms of this material to maintain the absorbed energy of an electromagnetic waves. With the device of concentrated colorimetry, we measure only optical density. Where we use this method in medicine? When we want to measure unknown percent solution of unknown percent solution of in this experiment we have kali potassium and optical density. Do you understand or not?
Yes, teacher.
All right. Now we measure first laboratory work. While Khalid, Faris, Jalad, open your open, please. Camera, open your camera. How are you, my dear?
I'm better.
Please, what is continuous current? What is continuous current? What we measured in the first experiment, ionophoresis or electrophoresis. A device of galvanometer works on the continuous current, yeah? What is continuous current? Do you know?
No, not yet, doctor.
No. No.
That's all right.
Sarah, can you ask me what is continuous current? Can you ask me what is continuous current? Natalie.